Good day, everyone. Welcome to another episode of Organic Chemistry. And in this very video, we'll be dealing with homologous series of organic compound, homologous series. So, what is homologous series? Homologous series are classes or family of organic compound whose successful members or successive member differs by a CH2 unit, by a methylene group, or by RMM of 14 gram per mole. These three things actually mean the same thing. So successful members, they differ by CH2 unit, and the meaning of this CH2 is called what? Methylene. And carbon atom is 12, hydrogen here is 1 times 2, 2. 1 plus 2 rather, 12 plus 2 rather will give us 14. So that's how we came about this 14 gram per mole. So we believe that homologous series, they are a family of organic compound whose successive members, for example, the difference between the first member and the second member is what? Is either a CH2, 14 gram per mole, or using what? Methylene. This is actually an examination question. So please, anyhow the question comes in, make sure you are able to tackle it so well. Then the first thing we have there is these are the properties of a homologous series. And please take note, the difference between this guy and this guy, that's what we call CH2 methylene and 40 gram per mole. Then the series is called homologous series. Why the members of the series, they are called the homolog. So the series is homologous series, while the individual members, they are called the what? The homolog. So let's quickly rush through the properties of homologous series. Number one, they have the same molecular formula. What I mean by molecular formula is that they have the same general formula. That means, for example, the alkane, all alkane have this formula. All alkane, they will definitely conform to this formula. All alkene, they will definitely conform to this formula. All alkyne, they will definitely conform to this what? To this formula. So what I'm trying to say here is that all of them, they have the same molecular formula. The same molecular formula. So that's the first one. The second one, each member differ by CH2 unit. That's what I just explained already. CH2 unit, comma, methylene, or what? 14 gram per what? Per mole. Then the third one, we have the physical property undergo a gradual change. The physical property undergo what we call a gradual change. The top members can be gases moving to liquid. Then the members with heavier number of carbon or more number of carbon can be what? Can be solid. So there is a gradual change in physical property. As you are moving down, the solubility can also change. A lot of physical property can change. A lot of them can change. Like the state of matter now. The first, for example, now the first four members in alkene, they are gases. Methane, ethane, propane, butane, they are all gases. So as you are going down, as you are moving down, you are going to get to liquid. As you are moving down, you are going to get to what? To solid. So there is actually a gradual change in the physical property of homologous series. Then the next one is that they exhibit general chemical property. So if the first member undergo combustion reaction, that is to say, the second member will undergo combustion reaction, the third member will undergo combustion reaction, the fifth member, the 100th member will still undergo that same combustion what? Reaction. So please, the chemical property doesn't change, but the physical property, there is a gradual change in it. Then the next one here, simpler member react rapidly than higher members. What I'm trying to say here is that here is CH4 and here is C3. Okay, let me increase this number a bit. C10, H22. You already know that this one, that the CH4 has a smaller RMM, relative molecular mass. But for this one, it has a higher relative molecular mass. So if they must undergo a chemical reaction, the one that has a smaller relative molecular mass will undergo, the reaction of this one will be faster compared to the one that have a higher relative molecular what? Mass. Let me quickly show you something that you need to know under this homologous series. For example, now using this formula Cn H2n plus 2. Let's say the value of n is 1. If you have C1 H2 times anywhere you see n, you put 1 plus 2. That will give us C1 H2 plus what? 2. Because this will give us 2. Then C1 H what? H4. Then if you change this one to 2, will now be C2H2 times 2 plus what? Plus 2. That will give us C2H4 plus 2. That will give us C3H what? H6. Let's increase this value to 3. Sorry. Let's increase this value to 3. We have C3H2 times 3 plus what? Plus 2. That will easily give us C3H6 plus what? Plus 2. That will give us C3H what? H8. Because 6 plus 2 will give us 8. So let's just take down all these values here. This one here, the first member is CH4. Second member is C2H6. While the third member is what? C3H what? H8. So now let's check. What is the difference between this carbon atom and this carbon atom? It's just one carbon. What is the difference between this hydrogen and this hydrogen? It's just what? 2 hydrogen. So that's why we call it the CH2 group. If you confirm this one too, you are going to have 1 carbon. If you confirm this one too, you are going to have what? 2 hydrogen. So these are successive members. They are called what? Homolog. They are called homolog. And this series is called the homologous what? Series. That is actually everything about the homologous series. If there's a part of it that you don't really understand so well, please feel free to drop that in the comment section. See you in the next episode. But for now, goodbye. I want to beg each and every one of us, if you have a friend that is yet to subscribe to my YouTube channel, please tell him or her to do so.